Neutron stars themselves are extreme laboratories of matter compressed to densities so intense that a teaspoon of their substance would weigh billions of tons. Collisions between neutron stars create gravitational waves that ripple through the cosmos, detectable across billions of light years, and forge elements like gold and platinum in explosive bursts of unimaginable energy. Yet even these dramatic events may be mild compared to other cosmic threats. Hypothetical quark stars or strange stars, theorized to contain matter in forms denser than neutron stars, could behave unpredictably. If such an object were to interact with ordinary matter, the consequences could be catastrophic, converting normal material into an exotic state and releasing energy on scales that defy comprehension. Black holes, often considered the universe's ultimate predators, are themselves deceptive in their danger. While they only consume matter that strays too close, their gravity distorts space-time, warps light, and generates tidal forces that spaghettify anything caught within reach. Supermassive black holes, residing at the centers of galaxies, anchor the cosmic structure, influencing star formation and galactic evolution. Yet, even these titanic objects pale in comparison to one of the universe's most speculative dangers, the metastable vacuum bubble. According to some theories in quantum physics, the universe exists in a false vacuum, a temporary equilibrium of energy. A sudden transition to a lower energy state, triggered naturally or by high-energy interactions, could propagate at the speed of light, annihilating matter and rewriting the fundamental laws of physics as it spreads. Such a phenomenon would be instantaneous, leaving no warning, no escape, an object not in the traditional sense, but a process encoded in the fabric of reality, capable of erasing existence itself. If the idea of the universe's deadliest objects intrigues you, 404 Altverse is the portal to explore these extremes. Subscribe and journey with us as we trace the candidates for ultimate cosmic danger, exploring their physics, their interactions, and the consequences of encountering energies far beyond human experience. Every observation, from gamma-ray bursts to gravitational anomalies, could be a clue to the presence of objects capable of reshaping reality or annihilating life on unimaginable scales. Even seemingly stable objects may hide cataclysmic potential. White dwarfs, remnants of sun-like stars, can reach a tipping point known as the Chandrasekhar limit. Surpassing this threshold triggers a Type Ia supernova, a thermonuclear explosion visible across galaxies. These explosions release more energy in seconds than the sun will emit over its entire lifetime. A supernova occurring within tens of light years could sterilize planetary surfaces, strip atmospheres, and irradiate entire biospheres, making the most dangerous object, a concept tied not to malice, but to proximity, energy density, and unpredictability. Gamma-ray bursts, among the universe's most energetic phenomena, exemplify this principle. Originating from collapsing stars or neutron star mergers, they emit concentrated beams of radiation that, if directed toward a planet, could extinguish life instantly. The challenge is that such bursts are fleeting, unpredictable, and capable of affecting regions across entire galaxies. Humanity's survival depends not on control, but on fortunate distance and orientation, factors entirely beyond our influence. The most dangerous object, then, may be one that exists quietly, unnoticed, yet holds the potential for total annihilation at a moment's notice. Furthermore, objects theorized but not yet observed may eclipse even these threats. Primordial black holes, remnants from the earliest moments of the universe, could range from microscopic to massive, carrying densities and energies unlike anything found in stars. Some may drift silently through interstellar space, their gravitational pull distorting nearby matter. If one were to enter the solar system, the consequences could be catastrophic, creating gravitational chaos, altering orbits, and potentially destabilizing planets. The danger is amplified because, unlike visible stars or known planets, these objects may be nearly impossible to detect until it is too late. Finally, the most dangerous object is not merely a measure of energy or mass. It is a combination of invisibility, unpredictability, and absolute potential for destruction. Humanity's perception of safety, derived from terrestrial experience, collapses entirely in the presence of such objects. We may understand their physics theoretically, calculate probabilities, and observe their effects at a distance, yet we remain vulnerable, infinitesimal in scale and fragile in consequence. The universe reminds us, through these objects, that survival is provisional, that existence is temporary, and that danger is not moral or intentional, but intrinsic to the cosmic order. The universe is a landscape of unimaginable extremes, where danger is not measured in intent, but in energy, scale, and unpredictability. While we can observe stars, planets, and black holes, there may exist objects or phenomena so alien, so volatile, that human perception cannot fully grasp their potential for destruction. Consider the possibility of interacting systems. A neutron star in orbit with a magnetar, their gravitational and magnetic forces combining in ways that amplify catastrophic energy release. Or a cluster of primordial black holes, drifting silently through interstellar space, occasionally colliding to unleash energy beyond comprehension. Alone, each object is deadly. Together, they create scenarios that defy probability and reason, reminding us that cosmic danger is often relational, emergent, and magnitudes beyond our comprehension. Gamma-ray bursts, neutron star mergers, and supernovae hint at this terrifying complexity. The universe rarely offers singular, isolated threats. Its deadliest phenomena are often interconnected, cascading across distances, affecting light years of matter and energy. A supernova in one system could trigger the collapse of a nearby star. A magnetar flare could destabilize orbiting neutron stars, setting off a chain reaction of high-energy events. The laws of physics allow for amplification, resonance, and instability on scales that are not just dangerous, but existentially catastrophic. Even a single misalignment, a slight gravitational perturbation, or a minor interaction could trigger consequences that ripple across the cosmos with total indifference to life or intelligence. Theoretical physics pushes the envelope further. Some hypotheses suggest that metastable vacuum decay, a sudden drop from a false vacuum to a lower energy state, could propagate instantaneously across the universe, annihilating matter and energy in its path. Unlike stars, black holes, or neutron stars, this is not a localized object, but a dynamic process encoded in the laws of reality itself. Its existence, though unobserved, is consistent with fundamental physics, and its consequences are absolute. In this context, the most dangerous object becomes less a singular body and more a latent property of existence, a reminder that the universe's potential for destruction may be woven into the very fabric of space-time. If the extremity of these objects fascinates you, 404 Altverse is your portal to explore them in all their terrifying detail. Subscribe and join us as we uncover the universe's most lethal phenomena, from magnetars and quark stars to the hypothetical instabilities lurking at the edge of reality. Each discovery, each anomaly, each observation becomes a window into forces that operate on scales beyond human experience, whose lethality is absolute, and whose indifference to life is total. Even speculative objects like ultra-dense quark stars or strange matter formations could harbor the universe's deadliest potential. Quark matter, theorized to exist at densities beyond neutron stars, could convert ordinary matter upon contact, releasing vast amounts of energy. A collision between such an object and a planetary body could annihilate the surface entirely, turning mass into energy and radiation in ways that would be instant, absolute, and catastrophic. Humanity's current technology, knowledge, and preparation are irrelevant in the face of such extremes. Survival depends entirely on distance, probability, and the unfathomable scales of the cosmos. Furthermore, the interplay of these objects may create secondary hazards. Gravitational waves from black hole collisions, intense radiation from magnetars, and shockwaves from supernovae can propagate across light years, affecting planetary systems without direct contact. The universe's most dangerous objects are not merely those that physically consume matter, but those that propagate destruction through subtle, cascading interactions. Life, planets, and even stars are vulnerable not just to collisions, but to resonances in energy and space-time, a reminder that danger in the cosmos is often hidden, emergent, and relational. Finally, the psychological dimension of cosmic danger is profound. Humanity has evolved to navigate terrestrial hazards, predators, storms, earthquakes. But nothing on Earth prepares us for objects whose scale dwarfs solar systems, whose energy could erase planets, and whose existence is indifferent to survival. The most dangerous object in the universe is not merely a scientific curiosity. It is a reflection of our fragility, a cosmic mirror revealing the limits of comprehension and the provisional nature of existence. To acknowledge such forces is to confront awe, terror, and humility simultaneously, to recognize that life, civilization, and consciousness are ephemeral in a cosmos filled with forces that operate on scales and timelines far beyond human understanding. There is a moment in every contemplation of cosmic danger when the mind must step beyond observation into speculation, when numbers and measurements give way to possibility, and when the imagination becomes both tool and warning. Beyond neutron stars, black holes, gamma-ray bursts, and strange quark matter lies a universe of hypothetical extremes, objects and conditions that may never be observed, but that remain entirely plausible under the laws of physics as we understand them. These are the corridors where the universe's full threat is revealed, where even light, matter, and time themselves may become instruments of transformation or annihilation. Here we confront the ultimate question: what does it mean for something to be truly dangerous when the canvas is the cosmos itself? Some theories propose entities that exist not as matter, but as pure energy configurations, compact and unknowable, capable of interacting with ordinary matter in ways that could fundamentally alter atomic and molecular structures. Imagine a phenomenon so subtle that it passes through planets unnoticed, yet leaves reality altered in its wake, a silent sculptor of destruction. Or consider the notion of white holes, theoretical opposites of black holes, which expel matter and energy into space at unimaginable rates. While purely hypothetical, they remind us that the universe is not constrained by intuition. It is an experimental canvas of extremes, limited only by the laws that govern it, and those laws themselves may be contingent, temporary, or local. Parallel to these objects, there exists the mind-bending possibility of vacuum decay. In this scenario, the universe as we know it exists in a metastable state, a false vacuum that could spontaneously collapse into a lower energy state at any moment. Such a collapse would spread at near-light speed, rewriting physics as it progresses, annihilating matter, energy, and structure across galaxies without warning. There is no advance notice, no warning sign, no chance of escape. It is a form of danger that transcends human-scale thinking entirely, because it is not a matter of proximity, size, or mass. It is a fundamental shift in reality itself. In contemplating these extremes, it becomes clear that cosmic danger is not a single thing, but a spectrum. It is layered, multidimensional, and often paradoxical. A supernova can create the very elements necessary for life, while simultaneously destroying neighboring planets. Black holes consume matter, yet help galaxies stabilize and evolve. Strange quark matter could propagate like a contagion, yet it is theoretically contained by the physical constants of the universe. Danger, in the cosmic sense, is entwined with creation, with energy, with the same processes that allow the universe to exist at all. Understanding this is not merely academic. It is a meditation on the fragility and wonder of existence. And if danger exists in these extreme forms, what does it mean for humanity? Our species, for all its ingenuity and resilience, occupies a tiny corner of a cosmos that can erase entire solar systems in the blink of an eye. We measure our lives in years and decades, yet the universe operates on scales of millennia, millions of years, and epochs so vast that comprehension falters. A gamma-ray burst, a rogue black hole, or a sudden shift in vacuum energy could undo everything in an instant, and yet here we are contemplating it, alive, aware, and capable of wonder. Perhaps this is the true marvel, that consciousness, however fragile, exists at all in a universe that often seems to be indifferent to it. Every fork in this path leads to another. Could there be forces, objects, or phenomena beyond even theoretical physics, lurking in the folds of higher dimensions, invisible to our instruments and imagination? Could there be forms of energy or matter that interact with reality in ways that are entirely foreign to human experience? Each possibility is a corridor into a universe of consequences, where understanding may require not only mathematics and observation, but an expansion of thought itself. If curiosity drives humanity, then it also carries the responsibility of humility, the recognition that no matter how advanced our knowledge becomes, the cosmos is far larger, far stranger, and far more dangerous than any human story can contain. And yet, there is a strange, humbling beauty in this contemplation. The very forces that threaten annihilation also construct the stars, the planets, and life itself. The same processes that could obliterate our species were they to occur nearby also create the oxygen in our atmosphere, the iron in our blood, the carbon in every molecule of life. Danger and creation are inseparable. They are two sides of the same cosmic coin. Understanding danger in this context is not merely a warning. It is an invitation to awe, to reflection, and to the cultivation of knowledge as both shield and torch. The philosophical implications are profound. What does it mean to exist in a universe where danger is omnipresent, scales dwarf imagination, and the very structure of reality can shift without notice? Perhaps it is a call to perspective, a recognition that our anxieties, conflicts, and fears, as real and immediate as they feel, are often small against the backdrop of cosmic forces. Perhaps it is a reminder that our curiosity, our desire to measure and understand, is itself a form of courage, a defiance of the indifference that surrounds us. By seeking to comprehend, we assert a fragment of agency, however small, in a universe that otherwise proceeds without regard for observation, morality, or intent. And yet, there is still room for speculation. Could the most dangerous object in the universe be something that has never been observed, something so subtle that its effects unfold across eons, invisible to the instruments of even our most sophisticated telescopes? Could it be a condition of space itself, a configuration of energy and probability, a phenomenon as quiet as it is catastrophic, whose presence is only revealed after consequences have already unfolded? The mind struggles to conceive of such entities, yet the mathematics of physics suggests their plausibility. Here, danger becomes abstract, philosophical, almost artistic in its unfolding, an invisible narrative written into the cosmos, waiting to be read by those who dare to look. This is the point where awe, curiosity, and fear converge. To consider the most dangerous object in the universe is not merely to catalog phenomena or speculate on theoretical physics. It is to confront the limits of perception, the fragility of existence, and the majesty of a cosmos that is as indifferent as it is intricate. It is to recognize that while the universe is filled with beauty, wonder, and elegance, it is also a stage upon which forces play out narratives that may be incomprehensible to us, yet utterly real in consequence. And the act of contemplating this, of standing at the edge of understanding, is itself a reflection of humanity's capacity for reflection, imagination, and courage. If this journey fascinates you, imagine where the next fork might lead. We are only scratching the surface of cosmic danger, of forces and objects that could challenge not only life, but the very rules of reality. Every choice in exploration opens new corridors of understanding, and every insight is a step closer to appreciating the delicate thread by which existence hangs. Stay with us as we continue to navigate these corridors, to measure, speculate, and reflect upon the forces that shape everything we know and everything we have yet to imagine. In the end, perhaps the most dangerous object in the universe is not simply a star, a black hole, or an exotic particle. It may be the concept itself of absolute scale, the recognition that existence is precarious, fragile, and profoundly contingent upon circumstances that are often invisible and uncontrollable. Danger is everywhere, from the tiniest quantum fluctuation to the most massive stellar explosion. It is embedded in the laws that make the universe intelligible, intertwined with the mechanisms that allow galaxies, stars, and life itself to exist. In this way, danger becomes a teacher, and fear becomes a lens through which to see both the vastness of space and the meaning of our place within it. And as we close this chapter of exploration, there is a final thought. The universe invites not only caution but wonder. Every object, every force, every hypothetical construct challenges us to expand our understanding, to embrace the unknown, and to recognize that while we are small, our capacity for curiosity and reflection is immense. The most dangerous object in the universe may be beyond our detection, yet in seeking it, in imagining it, in confronting its possibilities, we exercise the very traits that define our humanity: courage, curiosity, and the relentless pursuit of knowledge. The cosmos stretches endlessly, filled with danger, beauty, and mystery. And while we may never encounter its most destructive phenomena directly, the act of contemplation connects us to the universe in a profound way, reminding us that life, knowledge, and imagination are as precious as they are fragile. Every star, every burst of radiation, every theoretical singularity is part of a story far larger than ourselves, a story that challenges perception, defies intuition, and invites both awe and humility. So pause for a moment and consider. The universe is vast, indifferent, and full of forces beyond reckoning. And yet, here we are thinking, imagining, and daring to understand it. Perhaps the ultimate lesson of cosmic danger is not fear, but perspective, the recognition that existence itself is a miracle in a theater of unimaginable scale and power. If this exploration has sparked your curiosity, subscribe, and let us continue together, peering into the corridors of the cosmos, tracing the threads of creation and destruction, and confronting the sublime mystery of what it truly means to exist in a universe that holds wonders and dangers far beyond comprehension. Because in the end, the question is not just about the most dangerous object in the universe. It is about the way the universe forces us to see ourselves. Small, fragile, yet capable of wonder, reflection, and imagination that stretches across the cosmos. And that, perhaps, is the most extraordinary thing of all.